What if clean hydrogen could be produced more efficiently by using high-temperature heat, 200 to 1400 degrees C, that is already available at nuclear power plants, gas turbines, refineries and petrochemical plants, and industrial furnaces and kilns? Today, hydrogen production is energy-intensive and costly. Conventional electrolysers rely almost entirely on electricity, limiting efficiency and slowing large-scale deployment. METASIS is changing this. Funded by UKRI's EPSRC and developed at Robert Gordon University in collaboration with University of Surrey, Aston University and UK National Nuclear Laboratory, METASIS is advancing a next-generation solid oxide steam electrolyser, a high-temperature approach that combines electricity and heat to produce low-carbon hydrogen more efficiently. By engineering advanced materials, metasurface layers and structures, and robust tubular architectures, METASIS is designed for industrial-scale continuous operation. The project brings together leading expertise in materials, electrochemistry, systems modelling, and techno-economic analysis, creating a clear pathway from laboratory innovation to real-world deployment. To explore collaboration or learn more, visit rgu.ac.uk/METASIS.